Hi students, Dr. Madewell here, and I set the timer for 12 minutes, see how far we can go today. And today we're talking about correlational research, and this is a fun chapter. It's a simple chapter. We're going to be talking about how two or more variables relate to one another. Excuse me. As a note, also make sure you're preparing for the final, preparing your handwritten 8.5 by 11 cheat sheet. Okay, so be preparing. When we talk about a correlation, we'll talk about a correlation coefficient. You will denote that for a sample as a lowercase italicized r. Excuse me. If you're calculating population parameters, you will denote it with this little funny p. It's called a rho. But a correlation coefficient is going to be, whether it's your sample or a population parameter, it's a numerical index that reflects the degree of linear relationship. So is it a positive relationship, negative, or is it just no relationship? And it's also going to tell you the strength. So imagine this arm has a big muscle on it, or medium muscle or no muscle. So we're interested in the degree of the relationship and the strength. Imagine this was a big bicep. Our correlation coefficient, or the R, is going to range between -1 to +1.0. If you do your calculation and you say my correlation is 2.49, is that possible? Put that in your notes here. Where would you put 2.49? Okay, go ahead and answer that here on your notes. So show me that you're paying attention. If your correlation coefficient is a 0 or very similar to 0, it's going to mean that you have no relationship between your variables. As your value that you calculate or that you get from your SPSS output increases and approaches a +1.0, then you have a very strong positive relationship. So you'll notice there's two adjectives, strong and positive. That's a positive number. As we go left of our number line from 0, these are all negative numbers. As your correlation coefficient reaches -1.0, then it would be the max of a strong negative relationship. Okay. So you have two descriptors for your correlation coefficients: direction and strength. Direction and strength. I'm pulling all of these out so you can go ahead and be working on your notes. When we talk about R, or our correlation coefficient, nothing is being manipulated. All we're doing is observing how two or more variables are related. We want to see that both variables are related as X increases, Y increases, or as Y increases, X increases. We don't know which came first. If we have the chicken or the egg, we don't really know. But a correlation does denote a circular relationship. As you smoke or more cigarettes, your lung capacity decreases. So as you smoke more cigarettes, lung capacity is decreasing. We can see that that's a relationship. We know that from past research. As you consume more calories, what happens to your waistline? Calories, waistline, calories, waistline. Okay, there's a relationship. Okay. As you sleep more, we have better cognitive functioning. Okay, or as you sleep at 8 hours of sleep, as you're sleeping 4 hours of sleep, so as your sleep is declining, your cognitive functioning is declining. They go together. Because of this, we don't denote an IV and a DV. We just simply say that there's two variables in this relationship. So be careful on the final exam. This is kind of a tricky question. We want to make sure that you're understanding the differences between a t-test and a correlation. Make sure you're reading along in your chapter, okay? If we look at this scatter plot, so here we have our x variable and our y variable. Why I like classes to be live is that I can ask y'all what variable you'd like to say that's here. Maybe this is number of coffee cups drank in a week, and variable 2 could be number of hours worked in a week. Those don't, drinking coffee and the number of hours you work don't really need to be correlated. Okay, somebody down here at this spot right here could have drank one coffee, or maybe is that two? Does that look like two? Maybe 2 cups of coffee and they work 2 hours a week. If we look at the relationship between these variables, can y'all see a line? Could you plot a line here? The answer is no. There's no real relationship. If we were to just go target practicing with our shotgun, this would just be a shotgun blast on our target, right? This wouldn't show any real line between our two variables. Okay, so let's look at another example. Here we have variable x and y. As exercise increases, weight's going down. So this person here who worked out 4 hours, their weight is not going down. As this person who, let's see, is exercising 36 hours a week, their weight, like that's kind of a lot, right? That's a little too much exercise, but we could see, we could plot a line here. Could you see how we could plot a line here to show that this is a negative relationship? Oops, sorry. See here, let me try that again. Okay. And this person, as their distance is more from our correlation line, we could say that they're a little bit more of an extreme score. But we can see that there's easily a line that we could draw there. Go ahead and draw that on your notes, okay? All right. If we look here and we say, as exercise increases, food increases. Okay, let's go ahead and plot. Let me annotate again. It's taking me a little bit more time than I expected to get that going. Try not to hit my mouth. Okay, so we could say this is our line here, and we could see it's in a positive direction. Rise over run. As x increases, y increases. X increases, y increases. X increases, y increases. So if we exercise more, we're hungrier usually, right? Now, as these spots from each person, so each little spot is a person in our study. As people have distance from our line, our prediction line, we count that as error. And there's a lot of people right here on this line. When we look at how far apart our scores are from this line, then we could say that our strength is less. As our dots all fit on our scatter plot and make a nice tight line, then we have a stronger relationship between our x and y. Our value is closer to, this is a positive relationship, so it'd be closer to +1. On the previous slide, if as we're getting closer to the line with less error, then we could have a stronger negative relationship. All right, well, I'm going to stop video 1 here, And hopefully what you've learned from this video is that we have two terms that we want to use to define our correlation: strength and direction. Okay, strength and direction. Another thing for strength could be magnitude, which is in your book, but go ahead and be reading along, and we'll have a new video soon. Thanks.